Working on a 2006 Mazda 6 with the 2.3 inline 4 engine, non-turbocharged, no turbocharger. Having issues with one of the, what they call the intake runner circuit on this thing. Intake manifold tuning valve, actually, is what I'm having issues with. So how these work is there's two wires going to the solenoid, 12 volts from the fuse box, goes through the solenoid, and then the ground side, the computer controls the ground side. So I'm having issues with that, so I'm going to go over to the scan tool using the Autel MS906 BT for Bluetooth. We go to active tests, and then what I'm going to do is show you what I have going on, or I believe have going on. Scroll over. So the intake manifold tuning valve is one I believe is bad. These two are good. I'm just going to use those for comparing data. So I'm going to go intake manifold runner control, which I know is good. I don't need live data. Don't care. And if you pull it up, this solenoid is normally off. If you can see that, it's normally off. So I'm going to go back to the engine computer. It's controlled through a transistor for the ground circuit. Bear with me. Let me find the control side of the transistor, which I got right there. That is the control side of the transistor. If you look, I got no voltage. If I go over to the scan tool and I turn it on, I commanded it to go on. I should have a 4.5, 5 volt reference. Let me go back into the transistor. Back in that same port. Find it there. There's my 4.5, 5 volts. That's from the PCM turning it on. Now if I go to the base side, which is over here, and it goes around to this pin right there, which is 2I on the wiring diagram, I should have no voltage there. It should just be a ground, which is exactly what I got. Now, if I go back and escape out of this, I'm going to go to the known bad one now, the intake manifold tuning valve. I don't need live data. This one is going to say normally on, okay? You see it normally on. So I expect 4.5, 5 volts on the control side, right? Which is the other transistor, bear with me. So if you look there, 4.5, that's the control side. We got 5 volts there, 4.5, 5 volts. And I gotta get a good connection there. I got a bad connection. There we go. 5 volts, control side. That's normally on. If I check on the base side, which goes to 2J, this way, I should have no voltage there. It should just be a ground. If you look, I got 4.4 volts, so that gate in there is bleeding over. Well, if I turn this thing off, just to prove it turns off, I'm going to hit off here. Now it's turning off. If I go to the control side of that transistor from the PCM, same port, 0 volts, and I go to this same 2J circuit, so it's working there. I mean, it's not working, it's just there's nothing going through it. So obviously through this transistor, this bad one, there's voltage coming through this right here, through the control side and the base there, and it should not be. To prove that, this circuit up here, that's the same thing as the one we just tested, is normally on. So if I go over here to control side, I have 5 volts. Turn it on. But it's always on. If I go over here, like the other one we had 4.4, we shouldn't have anything here, because that's the ground side going to the wire to the solenoid, the other solenoid. I have 0 volts. So that transistor has to be internally shorted.